Night notes for problem 3.2, finding the longest factor string. Pause the video now and copy down these notes. Okay, so this is a really fun problem because it brings in some new math concepts. So the vocabulary here is factorizations, and that just means strings of factors. And here's an example for 100 again. We can go 2 times 50, break the 50 down to 5 times 20. So that would be an example of a factorization for 100. And you would write this as 2 times 5 times 20. So that's a factorization. We could also write it as a factorization just using a pair. 5 times 20. So 5 times 20. So moving along, so factorizations just means strings of factors. So a bunch of numbers strung together with multiplication signs. So what's prime factorization? Prime factorization is the longest factor string that you can possibly make. The longest factor string is prime factorization. So when you take a number like 100, which is a composite number, you break it down, you keep breaking it until you have only primes left. And this is a factor tree. This whole thing is a factor tree. So what you're left with here is you're left with all prime numbers. And this is kind of neat because when you take all of those prime numbers, so 2 times 5 times 2 times 5, you get 100. So where did I get these from? 2 times 5 times 2 times 5. So this is called the prime factorization. And we're almost done, but not quite. We are introducing another concept. In this case, it's a vocabulary word, but it's called exponent. And I know you've probably heard of that, but an exponent tells how many times a factor has been used. So if we go back to this original string right here, which is 2 times 5 times 2 times 5, that does equal 100. But we don't want to write it like that. We want to clean it up. So what we do is we take the 2, I'm going to write it over here, 2 times 5 times 2 times 5. Well, we have 2 2's and we have 2 5's. So we use exponents to tell us how many times a factor has been used. Remember, all these are factors that we're multiplying to get 100. So our final answer with exponents would be 2 to the second power times 5 to the second power. Or you can say 2 squared times 5 squared. This is the exponent, and the 2 is the base, and the 5 is the base. So exponent tells us how many 2's we had. 1, 2. How many 5's do we have? 1, 2, 2. Oops, what happened here? Both are prime. So this is a picture from your notes packet, and it talks about factorization again and prime factorization. Next to each number, create the longest factor string possible. This is called the number's prime factorization. I'll do 48 for you. So for 48, you keep breaking it down, and I just use 2. I see 8's an even number, so I say 2, or 48 divided by 2 gives me 24. So 2 times 24 is 48. This is prime, and I like to teach students to circle the prime number when you know you can't do anything more with it. 24 is 2 times 12. Circle the prime. Break down the 12 is 2 times 6. Circle the prime. And last but not least, we can break the 6 into 2 times 3. and both of those are prime, so we could circle both of those. So what we see here is all of these prime numbers, prime. Now we'll put those into a long string and we'll use exponents. So I have 1, 2, 3, 4 2's. So if we have 4 2's, we say 2 to the 4th power times what's left. We have a 3. So 2 to the 4th times 3. 2 to the 4th times 3. And that little 4 is called the exponent. It tells us how many 2's we had. Isn't that cool? Let's do another one for 100. All right, so for 100, you can watch me do this in real time. I say, okay, let's go 2, because I know this is an even number, so it's divisible by 2. So 2 times 50. I'm going to circle the prime. That's done. 50. 2 times 25. I'm going to circle my prime number. I'm going to keep breaking them down. It's like hitting them with a sledgehammer. 5 and 5, they're both prime. We're done. Now, how do we write that with exponents? We count up our 2's. We say 1, 2. So we have 2 2's. So we can say 2 to the 2nd power times, and how many 5's do we have? 1, 2, times 5 to the 2nd power, or 5 squared. So 2 squared times 5 squared is the prime factorization of the number 100. So the last number I've factored for you is 840. So you say, okay, it's even number. 2 times 420 would give you 840. I like to circle my prime. Break the next one down. 420 divided by 2 is 210. So 2 times 210 is 420. Circle the prime. 210 can be broken down. It's an even number. 2 times 105. Circle the prime. 105. Now 105 is divisible by 5. So I said 5 times what? 5 times 21. Circle the prime. And last but not least, the 21. Break that down into 7 times 3. 3 and 7 are both prime numbers. So I like to circle those. And then we write it using exponents. So I have 1, 2, 3, 3 2's. So I'm going to say 2 to the 3rd power times, I have a 3, a 5, and a 7, only 1. And I like to have you always write them in smallest to largest. So 2 to the 3rd power times 3 times 5 times 7 is the prime factorization of 840. Okay, moving along. So there is another method other than the tree method, and I've shown you the tree method several times. It's the division method. So it's the same thing, except you just keep dividing, kind of upside down division, until you get all the primes on the outside. I'll show you one of those. So here's an example of 30. So I wrote 30 divided by upside down division 2 gives me 15. 15 divided by 3 gives me 5. So our final division method, we would have 2 times 3 times 5. So the prime factorization would be 2 times 3 times 5. Let's do another one. Let's pick the number, let's do 45. So 45 divided by 5 gives me 9. 9 divided by some factor, let's see, 3. 9 divided by 3 is 3. So those are our final factors. They're all prime. So then we would say it's 3 squared times 5. It's just another method if you don't like the tree method. All right, so in this video, we have done what's a factorization, what's prime factorization, what's prime factorization using exponents, We looked at the tree method in several examples. Here's a couple more that breaks it down. One thing I don't do is I don't usually bring the number down after the first one right here. I just like to teach circle it. I don't bring the numbers all the way down. I just say, oh, I shouldn't have erased that. I would just say circle that 2 once it's prime. So this is all extra stuff for me. So in your notes packet, why don't you practice using the division or the tree method to find the prime factorization of 360. So the prime factorization of 360, give it a shot. And then write your final answer right here. So you would start off maybe by saying, okay, 360, so 36 times 10. It doesn't matter which factors you pick as long as you keep breaking them down. 6 times 6. 5 times 2. Okay, those are prime. I'm circling them. 6. Oops, I'm going to go to black here. 2, 3. Circle, they're prime. We're almost done. This 6 has to be broken down. 2, 3. Circle them, they're prime. So we count up what we have. We have 1, 2, 3 2s. So that would be, I don't want that color. We want 2 to the 3rd power times, what else do we have? 1, 2, 2 3s times 3 squared times, what's left? We have a 5 hiding there, times a 5. So this is the prime factorization of the number 360. Thank you for watching this video.